Hello and welcome. In this video, I will talk about the transformations of functions. I have prepared this lesson for my grade 12 students who are taking the Advanced Functions course, MHF for you. This is the math you take in grade 12. It leads to university preparation. You usually take this course either before you take calculus or while you take calculus. Better before, I would say, but that's my opinion. This will serve them as a review of prerequisite skills because you have learned transformations of functions in grade 11. So this lesson can also be used by students who are taking the grade 11 functions course, MCR3U. That's the math you take that leads to university preparation. And I must add that it can also be used by the students who are taking the MCF 3M course. This is the math you take in grade 11 that leads to both university and college preparation. So let's get started. Remember that in grade 11 you were introduced to several groups of functions which we call the parent functions. And we also reinforced the idea of using functional notation when we described different types of functions. And the functional notation is something that looks like this: y equals f of x. And here we clearly indicate that f of x is just another name for y. Now, all parent functions of the form y equals f of x can be transformed according to this equation given here. Y equals a f of kx minus d plus c. As you see here in the y equals f of x equation, we have inserted the coefficients a, k, d, and c, which will cause different types of transformations to f of x. Let's get started with the first coefficient, the coefficient a. When a function has undergone transformations caused by coefficient a, it means that the function goes from y equals f of x to y equals a times f of x. Now remember that f of x is just another name for y, and you multiply f of x by a, it means that you're multiplying the y variable by a. Now that tells us that the coefficient a will change the function in the y direction, or even better, in the vertical direction. How would the coefficient a change the values of y in the vertical direction? Well, pretend that this is a number line that represents the possible values of a. Imagine that if a equals 0, then no matter what f of x is, then the function will become y equals 0. So here we go. If a equals 0, then the function will become 0 times f of x, and anything multiplied by 0 will equal 0. So this function will change to become y equals 0. And y equals 0, we know that is a linear function. So if a equals 0, we're going to say that the function will change its nature. So if it was exponential, it will become linear. And that's why when we are on the number line, we exclude the value of a equals 0, because it will be insignificant to the transformation that a might cause in here. It will change the function itself. And to do this, we draw an empty circle around 0. Other key values for a would be the value of a equals 1 and a equals negative 1. If a equals 1, imagine that a is in here. We're multiplying f of x by 1. So that makes the function y equals f of x, because 1 times f of x equals f of x. Now that tells us that the function is not changing shape at all. So when it comes to describing the shape of the function, again, we are going to draw an empty circle around a. And the same thing happens when a is negative 1. So when you multiply by negative 1, the function f of x, so if you have y equals, -1 f of x, again, the shape of the graph has not changed. It's just the orientation of it. So we're going to draw an empty circle in here just to indicate that the shape of the graph will not change in there for y equals negative f of x. Okay, other transformations will happen, but we'll talk about it. So with this being said, then we're going to say that the key values that will actually lead us to determining the transform or describing the transformations caused by A would be here at 0, -1, and 1. Okay, so I'm going to clean up this just so that we won't get too confused and the chart doesn't get too overwhelmed with information. So if A is bigger than 1, so for these values of A, or less than -1, imagine that we are going to multiply y by a number such as 2 f of x, or 3 f of x, or 4 f of x. So the values of y will become 2 times bigger or 3 times bigger for the same x values. So that will cause a stretch in the vertical direction of the function. We call this a vertical expansion, and I know different textbooks will use different words. I think expansion is a better word to describe it. It's more precise. The same thing happens if the function has a value less than -1. The function will undergo vertical expansion. So I hope this is kind of easy to see and understand it this way. Now, if the a values are between -1 and 1, always excluding 0, then we're going to say that the function will undergo what we call a vertical compression, because the values of y here will be multiplied by numbers such as 0.5 and then f of x. So the f of x will be shortened by half, or 1/3 f of x, or -3/4 f of x, and so on. Now, what happens when a is negative? When the values of a become negative, then here they are. Imagine that we have y equals f of x. If they become negative, some value of a f of x, now all the y values will be multiplied by a negative number. So if a point happened to be above the x-axis, that's where all the values of y are positive, then they will have to go to the other side of the x-axis, because that's where the y values become negative. So if this was a point a f of x with a positive, this will be the negative a f of x with a negative, just to say. Okay, so in this case we say that the function undergoes a reflection, because the points will go from one side of the axis to the other, and the reflection will be about the x-axis, because it is the y values that will change or switch signs from positive to negative and vice versa. The next coefficient that we'll talk about is the coefficient k. So if we have a function y equals f of x, the coefficient k is inserted right before the coefficient x in here, kx. K is the x coefficient, and as a result, the changes in the values of k will affect the values of x. Imagine that if you multiply x by k bigger than 1, the x values will expand, right? So they will become bigger. So for the same values of x that we had before, now we have x empowered by k, so the y values will be reached faster. So if k is equal to 0, that will change sort of the meaning of the function. That might change the meaning of the function, because very often the term that contains x carries the nature of the function. Let's say, for example, y equals x squared, right? So if you multiply x by 0, then the x squared term won't exist anymore. So if k is 0, that changes the nature of the function. So we are going to exclude that value from our discussion of coefficient k. Now, if k equals 1 or negative 1, there won't be any stretches caused to the function. Now, since k is the coefficient of x, then we must remind ourselves again that k will cause transformations in the x direction or horizontal direction. And since it is multiplication, okay, k times x, it will cause stretches. If k is bigger than 1, again, we don't discuss equal to 1 because there are no changes in the shape of the graph. If k is 1 or negative 1, we are going to say that the function will undergo what we call a horizontal compression. And that's because the same y values will be reached for smaller values of x that will cause the function to compress in the horizontal direction. The height of the graph will not change. It's just the compression in the horizontal direction. Okay? The same thing applies to negative values of k beyond negative 1. So a horizontal compression. The graph will become narrower, not taller, just narrower. If the k values are between negative 1 and 1, again 0 excluded, the graph will undergo a horizontal expansion. So the graph will become wider. So remember that the coefficient a can make the function taller or shorter, and that's because y values will become either greater or smaller, and the coefficient k can make the function either narrower or wider. The height again won't change. If the coefficient k happens to be negative, the graph will undergo what we call a reflection. And if you think about it, the reflection will be about the y-axis. It's a reflection of x-coordinate. So imagine having a graph somewhere here, and there are points on the graph somewhere here. So if you are reflecting the x-coordinates of these points, that means that this point will go to the other side. This point will go to the other side of the y-axis. So the x-coordinate will become opposite. That's why we call this a reflection about the y-axis. And some people prefer to call this a reflection of x-coordinates, which is totally fine. It's correct. It makes sense. Okay. I usually try to stick with one way of describing a transformation so that I won't mix them up with each other. The next transformation is the transformation called by coefficient c. The coefficient c causes a vertical translation, and the reason why is because the function goes from y equals f of x to y equals f of x plus c. So the y values are added here. The y values, f of x, are added a number. When you add a number to the values of y, remember that you're adding that value to every point on f of x, the graph will tend to shift in the vertical direction. So if this is a number line that represents the coefficient c, and here we have c equals 0, which means no translations. When c is bigger than 0, we're going to say that there will be a vertical translation up. And when c is less than 0, the vertical translation will go down. The graph will shift down every single point of it. Now, the last transformation that we'll talk about is the horizontal translation, which is caused by the coefficient d. Now, let's take a look at where the coefficient d is placed in the transformation or in the transformed equation. So y equals f of x, which is your parent function, will become y equals f of x minus d. So in this case, you are subtracting a value of d from x. So that's why it's a horizontal change. Pretending that this will represent the values of d, and this is 0 right here. And I'll draw an empty circle in here to indicate that 0 won't cause any translations. We are going to say that if d is a positive number, the function will move horizontally to the right. So horizontal translation right. And if d is negative, that would be a horizontal translation to the left. And every time I say this, my students start singing the song to the left, to the left. For some reason, it has stayed alive for so many years. So now we have to watch out for identifying the coefficient d because it's one of the most misunderstood coefficients. Imagine that you have the function y equals f of x minus 3. Now, how do we identify the coefficient d? Remember that in the equation here you have minus d. So in this case, we're going to say you are minusing the number 3, and number 3 is positive. So with d equal to 3, we're going to say that the function will move to the right. Now, the reason this coefficient is misunderstood sometimes, or is gotten wrong, is because of the minus sign in here. Whenever we see a minus, we think moving in the negative direction. But remember that the minus that you see in this equation is this minus that is in the original transformations equation. So your d value will be whatever comes after the minus. We can see this way. Now, if you have y equals, say for example, f of x plus 5, so when you see the plus in here, we think, oh, it's a plus, it's positive. But no, in this case, what this actually means is f of x minus negative 5. So that's where the positive comes from in here. It comes from the two minuses. So with d being negative and the minus in the equation, we see a plus in here. And we're going to say that d is negative 5 here. And d negative 5 will cause the graph to move to the left. Now, last but not least, I just want to remind you that the reflection can be about the x-axis. The reflection is about the x-axis when a is negative, less than 0. And you can call it a reflection about x-axis or reflection of y coordinates. It is very important how we say it because every math term carries a meaning, and a slight change in it can change the meaning of the whole thing. But if we pay attention to how we say or how we describe or how we use the math terms, then we can also see the meaning inside it. So we don't need to memorize a lot of things, okay? So if we understand the meaning of every term, then we'll understand what that term is used for and how to use it as a result. The reflection will be about the y-axis when k is negative. We also call this a reflection of the x coordinates. Okay, so this is all about the transformations of functions. And I'm going to just make up an example in here to consolidate our understanding. So pretend that we have some parent function y equals f of x, and we have transformed it and made it into y equals a, I'm going to give that a value here, well, negative 2 f 1/3 x minus 4, and then plus 1. We're going to say that if a is negative 2, I will highlight it instead. And a of negative 2 causes a vertical expansion 2 times taller and a reflection about x-axis. The next one is the coefficient k, 1/3. That would be a horizontal expansion 3 times wider. No reflections because k is positive. The next one is d of positive 4. So we're going to say that's a horizontal translation to the right, 4. And last but not least, we are going to mention in here the coefficient c, which will make the function move vertically or translate vertically 1 up. Okay, so this is it about transformations of functions. I hope everything made sense, and